Today we're going to talk about two sample t-intervals for the difference of two population means. So you should think of this as going along with the two sample t-test. Sometimes these are just called two sample t-intervals. So let's take a look at this problem here. College financial aid experts expect students to use summer earnings to pay for college. How large are these earnings are the questions. So in one large university, studied this question by asking a random sample of 1,296 students who had summer jobs how much they earned. And then they based the responses into two groups on gender. We can see here there were 675. You can see this number here. There were 675 males. On average, they made $1,884.52 for the summer, and the standard deviation of their earnings is right there. And then you can see a similar set of data for females. Looks like they have a lower average and so forth. A fair question so question A is sort of an interesting question. How can you tell from the summary statistics that the distribution is strongly skewed to the right? Well, without even having the graph or a box plot to look at, that is, you know right away that the standard deviation, let's just look at the males. The males have a mean of 1884 and a standard deviation of about 1370. So if you're going to try and draw, say, a symmetric distribution with those properties, 1884 in the middle, get a standard deviation. Well, let's use the correct symbol because it's a sample standard deviation. So I should say S of X was about 1370 or something. So if I subtract it once, if I do 1884 minus 1370, you get 514. And then if I try and subtract it again, I run into trouble because I end up getting a negative amount and of money earned. And so we're only keeping track of the money they earn. This can't be negative. You can tell already this graph kind of has to stop somewhere around here, around $0. Maybe that's over a little bit. And therefore, is no way it could be skewed. It could be symmetric. And additionally, you've got a mean of 1840, but a really big standard deviation. So there must be some really big numbers out here pulling up at the mean and making the standard deviation large. So that's why you know this thing has got to be really skewed right. So the real graph looks something like that. That's what you'd expect. Okay. More importantly, what this video is about is part B. Construct and interpret a 90% confidence interval for the difference between the mean summer earnings of male and female students at the university. So what do those confidence intervals look like? Here's the basic format of them. So I'm going to call it X bar sub males minus X bar sub females plus or minus T star times S of X bar males minus X bar females. So this is a standard error of the difference in the two populations. So how do you compute this thing? Well, we know already that you can only add variances. So it's going to be kind of the same thing we did when we looked at two sample t-tests. So add variances. All right, so let's give this a shot. Let's take these numbers and see what we can do. So let's give it a shot here. All right, so S of X bar males would be the standard deviation for the males, 1368.37, divided by the square root of the sample size of the males, which is 675. So if we calculate that number, we get about 52.67. Now you need to do the same thing again for the females, so S of X bar females. So that's going to be 1037.46 over the square root of the number of females that were interviewed, which is 621. And if we take a minute to divide those numbers, we get about 41.63. So now you've done all that, you're ready to compute your standard deviation of the difference. So, oops, sorry about that. So S of X bar males minus X bar females would be the square root of the sum of the variances. So you're only allowed to add variances, that's it, even if your variable is interested in the difference. Let's see what we get for this. So this turns out to be about 67.14. So that's good. We're on our way to building our confidence interval. So let's go back and look at the format of it again. It's this thing right here. So we need to do X bar males minus X bar females. So that's going to be 1884.52 minus 1360.39. You can see those numbers right there. So those are those numbers. If we subtract those, we get a difference of 524. So we have 524.13 plus or minus. We're going to need T star. And then our standard deviation we calculated a moment ago was this number 67.14. So I'm going to put that in here, 67.14. And now we wanted a 90% confidence interval. Well, to do that, draw a picture of a T distribution. We shade in the middle 90% of all area, and we ask ourselves how much area is in the tail. So in that case, you would have an area of 1 minus 0.9 over 2, so it'll turn out to be 0.05. So that's how much area is in this tail and this tail. And what you want is you want the T star that goes here to get that amount of area. And there's two ways to do it, really. One thing you could do is use a chart. So let me show you how you use a chart. Okay, so I have one here. And what you do is you go down to the bottom of the chart. At the bottom of the chart, you'll see a number here. Extend this a little bit. You see the word confidence level, and then we'll look at 90% because that's what we want here. The only issue you have, though, is you have many, many T stars. These are all the T stars in this row here. So in order to pick out the correct T star, you need to go to the top of the chart and realize you need to know something called the degrees of freedom. Okay, so the degrees of freedom, you always take your two n's. In our case, n was, for the males, 675. You can see that there. So n for the males was 675. N for the females was 621. You pick the smaller of these two numbers, which in this case is 621, and then you subtract 1. So 621 minus 1, or 620, and those are your degrees of freedom. Now, sort of an interesting problem presents itself because when you look at this table and you look at the degrees of freedom column, you see a number of 1,000, you see a number of 100. So what do? It actually doesn't matter because some statisticians will tell you we'll just round to the closest number. So 621 is closer to 1,000, so we'll use the lower number of 1.646. Other people will say, well, you should always round down to be safe, so you can use the 1.660. Either one is going to be fine. I'm going to round down and be safe here. So 1.660 is what we're going to put in here. And then this thing here is our confidence interval. So what I'm going to do now is calculate that. And I'm getting about this 412.68 up to 635.58. And so what we can say is that we're 90% confident that the true mean difference in the amount of money that males make during the summer versus the amount of money that females make during the summer is somewhere between 412.68 and 635.58. So notice in here that this interval does not contain 0. So that's telling us that it's not likely that the difference in the amount of money that males make during the summer and females make during the summer would be 0. It's unlikely that difference is 0 because it's not in this confidence interval. So that would lead us to reject any claim that males and females are making equal amounts of money during the summer. What this is sort of showing us is that they don't, and that the males on average make more money. Uh, a fun question you should always think of when everything about confidence intervals. 90% is pretty confident. Let's say you want it to be more confident. You said to yourself, I'd like to be, say, 99% confident that we've captured the true mean. So that confidence interval, everything about it would be the same. So you would take this format here, these numbers. So let's remember those: 524.13, 524.13 plus or minus blank. This was 67.14. Let's see if I'm remembering that correctly. I am. There it is. Okay. And now I need to get the confidence interval, or the confidence, or I should say the T star, sorry, for the 99% confidence interval. So let's go down here. We'll go to the 99% column, and the two numbers are 2.581 and 2.626. I'm going to use 2.626. And already you can tell if you look at these two intervals, if we look, let's say I circle this 1.660 here that I used before, that was for 90%. And here now I'm using 2.626 for 99%. You can tell already this new interval is going to be wider. And that's a really important concept with confidence intervals. You should know that if you want to be more confident that you've captured the true mean, then you need a wider interval. So if I go to calculate this, the lower bound I'm getting is 300. Oops, that's an error. Sorry about that. Is 347.82 up to, and we're getting 700.44. So what would we say here? We're 99% confident that the true mean difference in the amount of money that males make during the summer and females make during the summer is somewhere between 347.82 and 700.44. Notice again, this interval still doesn't contain 0. So now we're really confident that the males are making more money than the females during the summer. Thanks for watching.